My name is Albeda Siddiq. I'm a senior solutions architect at AWS. This use case is about AI orchestrated complaint prediction and service assurance automation. Now, when I meant complaint prediction, what I mean by that is that some of these customers haven't complained yet, but based on our experience with other customers in past, we expect or we anticipate that these customers would eventually complain based on the network experience they're feeling right now. This use case brings in the service management area as well as the network management side to streamline the process end to end. And this solution was built by RADCOM and other partner ServiceNow, all on AWS. What challenges are we solving here? Often network problems will become service tickets, but people that are working on the service tickets don't have often the visibility of the core data or RAN data, which kind of slows their investigation process, which also means there's more backlog, and typically that puts more pressure on them. But also they may not be working on the right ticket. What I mean by that is that they don't have the visibility of the prioritization of 10. That means there may be other tickets out there that has a wider customer's impact, and maybe they're not addressing them, which means that customers in that segment are becoming more and more frustrated, which also increases the chance of their churn. So how do we solve this problem? So as I mentioned that this was built by ServiceNow and RADCOM. So we took the data from ServiceNow ticketing system, but then we also brought the data from the service assurance, which is kept in RADCOM. Using those two data, we built an AI model. And this AI model is what we use to predict the customer's complaint, and then we feed the data back into ServiceNow for customer 360 view, but also we push that data back into RADCOM for the network analysis and insights. Okay, so let me take you to the demo, and I can come back to see how this was actually implemented at the end. So as a customer success manager, I have a few accounts that I always look after, and I start to look at some of those enterprise accounts, and I want to see how their network health score is. And as you can see, some of them are turning yellow, which as a success manager, I'm a bit concerned now. I want to know what's happening with these customers. So I go into the first one, GenXify, and I start to look at an executive there, Jen Gray. And again, these are all fake data or fictitious data for demonstration purpose. But I can see there's some alerts being generated against that account, which for Jen Gray. So I want to know what's really happening with Jen Gray. So I go there. And interestingly, Jen Gray has some of the services such as video service, data service, and also voice service. But as you can see, out of all the services, the voice services performance has slowing down or is degrading. But other services are reasonably okay. But if you look at the whole model, what model is predicting that based on all the informations, there is a 90% chance Jen Gray is going to complain. Right? Again, that's where that AI model that we built came into play. So as a network operation team, I want to know what's triggering this 90% propensity to complain. Why Jen Gray is thinking like that. So for me to find out, I want to go into RADCOM screen where I would come into a natural language processing chatbot that we have built for the solution. I can ask that question, hey, why isn't Jen Gray, what is the likelihood of Jen Gray to complain? And it kind of confirms that, yes, based on what we're seeing, 90% chance that Jen Gray is going to complain. But why? And it kind of gives you a summary that there is a poor signal quality in certain areas. That could be one of the contributing reasons. So I want to drill down a little bit more. So I go into look at some of the features, what's causing this degradation in the network. And I can see that Jen Gray is spending a lot of time in 5G network, but some of this 5G just been launched and deployed. So there's some quality issues in that segment. And that is one of the main reasons Jen Gray network experience is not ultimate, but also we've seen some other attributes such as the data packets loss. As you can see, the kind of the blue part is kind of showing all the factors that are contributing to these network experiences. But I still don't know why GenGray would complain. So then I will go and look at my reference subscribers in the past. Based on all the subscribers that I had in the past, they have very similar experience with GenGray. And it kind of shows the similarities as an example you can see. And all these customers actually complain at the end. So this model now predicting based on that data point saying, yeah, there's a good chance that GenGray is going to complain. So then as a network operation manager, I'm thinking, well, I know there's one customer I'm worried, but what about my whole network? How is my network behaving? So I can go there and I want to see heat map of my network, especially in the Ireland area. I kind of drill down and I can see some of the red dots are forming here, as you can see. And this is all in Dublin area. So there's some red dots, cluster of red dots around Dublin area. That is where we think that customers, most likely would complain based on what the data point is. And then I want to know what are the top 5 reasons in Dublin that people might complain. And it kind of echoes the same thing, the 5G issues and the data drop issues and the call drop. So those are the contributing factors again. But now, instead of doubling, I want to know, top 5 markets where this actually happening besides Dublin. Show me all the top 5 markets. And it kind of highlights the Donegal as an example, which has an 11.59% chance the customers from the Donegal market will complain, right? And it is the kind of the most problematic region right now. So I want to know what are the sites that are contributing this issue. So then I go to this query now. This is all again natural language query powered by Bedrock. And I start to look at some of the analytics here that it can highlight some of the sites, has 200 customers, and also the likelihood of some of those people complaining like 50+%, right? So you start to tie up the story pretty nicely. But at the behind the scene, what this model has done or this RADCOM solution has done, they have triggered an events back to ServiceNow. So basically all the issues now get propagated back to ServiceNow, where as a service management team, I have visibilities. So that's where I will go back to ServiceNow screens, and I can see there are some of those events that I showed in the RADCOM screen also get populated here. The data is coming from RADCOM, different sites. So now it starts to make sense. But what I'm going to do with this, I need to take some proactive actions. And as you can see, ServiceNow behind the scene already generated alerts. And from the alerts, it created some automated work orders and tasks. As an example, go send some field technicians, first task, fix the site, but also add more capacity in the region, as an example. So the beauty of this is that it is through the AI, it understands all the events that came from RADCOM, but then built in orchestration flows to how to handle that event, how to handle the alert behind the scene. So that is, the proactive way we're handling the automated assurance on the network. But then if you look at the architecture, how do we do this? So again, the data came from ServiceNow. We took the demographics data. Also, we took the network performance data from RADCOM. We took all those data. We use our SageMaker machine learning capabilities using the PyTorch. And then we use the GPU-powered EC2 instance to train the model. But also we did a batch inference to support those inference capabilities. But then we kind of nicely tie them with Bedrock capabilities, where Bedrock using in many choice of LLMs, in this case we use cloud. Using the LLM capabilities, we drove insights into that, but also we use that agentic experience that we have with Bedrock Agent to use the RAG capabilities, to use the RDS vector embedding to mine the data, but also we ensure that data is secured and private using the Bedrock guardrails. So that kind of enabled RADCOM and ServiceNow to bring the solution quickly to the realization using some of the capabilities that AWS has provided them. So what is the outcome of this? As you can see, some of the benefits that our partner RADCOM has seen by dealing with their internal test data and also working with their customers. Based on the initial test data, RADCOM mentioned that they have seen 30% reduction in ticket resolution time. Now, why is that? Because it brought in the service management part, also streamlined with the network operation part. With that, they're able to reduce 30% the ticket resolution time. But also, since the model can predict the network issues, before it happens, they're able to see in the test results that it's reduced 40% ticket volume. But also, since now the customer has better network experiences, based on their discussion with customer, they're also saying they anticipate there will be 3% churn reduction in operators environment, which could be a lot of dollars at the end. Thank you, and hope if you have any questions, please feel free to reach me in AWS.